Let's go ahead and knock out lesson 9-4's homework. There's quite a bit of it, so it's going to be a little lengthy. We'll start with 1 through 4. Find the value of complete C. Well, remember, when we're finding C, we're using that formula. We're going to take our B value, and we're going to divide it by 2, and then we're going to square it. So when we do this, we're having 12 divided by 2, which we know is 6, and 6 squared is 36. So number 3 should be 36. We'll do number 4. Number 5 says, complete the square of the expression, complete the factor of the trinomial. If we're completing the square, well, this is going to be fairly easy. We've got x squared minus 10 squared. We're trying to find c, so we're going to take 10 over 2 squared. This is going to give us 5 squared, because 10 divided by 2 is 5. 5 squared is 25. So this is going to be x squared minus 10x plus 25. All right. Number 6 is yours to do. Six is yours to do. Let's move on. Solve the equation by completing the square. So if I'm completing the square of x2 plus 14x equals 15, and I'm going to complete the square of 14. Well, 14 divided by 2 is 7. 7 squared is 49, so we're going to add 49 to both sides. All right. Now that we're adding 49 to both sides, 49 plus 15 is 64. Now we're getting the square root. Well, basically, what binomial multiplied to itself will give us this? We see that we're going to take the value here for x. Right? We put it there, and then we find the square root of this number. Square root of 49 is 7. And then we use the sign that's in front of this number. So that's a plus. So x plus 7 squared equals 49, or 64. Now, we're going to go ahead and get the square root of both sides. Right? So when I get the square root of a square, I'm canceling these out. Simply put, this and this are going to go away. Okay? And now the square root of 64, well, that's going to be 8, so it'll be plus or minus 8. So now we have x plus 7 equals plus or minus 8. This gives us two problems. One is x plus 7 equals 8. So I'll subtract 7 from each side, which will give me a 1. The other is x plus 7 equals negative 8. And when I subtract 7 from each side, I'll get a negative 15. So we see that negative 15 and 1 are both possible answers. Number 12 is yours to do. Number 13, we're going to take this negative 4, divide it by 2 to give us negative 2, and that's square. That's going to give us 4. So we'll be adding 4 to both sides. Okay. 4 minus 2 is 2, so 2 will come over here. Then we'll find what binomials we can go ahead and factor into this to, that multiply to itself. So we'll get x minus, and a square root of 4 is 2. So x minus 2 squared equals 2. Now, of course, we get the square root of both sides. And we do, again, the 2 and that square root sign are going to cancel out. This will stay the same. There is no square root of 2, so it will remain plus or minus 2. And we'll have x minus 2 is equal to plus or minus 2. And now we'll add 2 to both sides. So this will be 2 plus the square root of 2 and 2 minus the square root of 2. Number 14 is yours to do. Now number 15 is to solve by completing square. We're going to take that negative 5 divided by 2. And then we're going to square that. Well, this is going to be a little bit different in that we don't have an even number. So when we do this, we're going to have 5 over 2 squared, which is going to leave us with 25 over 4. Okay. Okay, so now we got to figure out, well, how do we add 8 to 25 over 4? We're going to multiply 8 to 4 over 4. Okay, so those that don't remember how to do that, we're taking 8 over 1, multiplying it to the 1 in the form of 4 over 4. And this gives us 32 over 4. And now that we can add with 25 over 4, because remember, we need common denominators to add or subtract. So we're going to be taking that 32 over 4, adding it to 25 over 4. We got the square, we found and factored in the x, the negative sign, and then square root of 25 is 5, square root of 4 is 2. And now 32 plus 25, that's going to give us 57. And now we're going to get the square root of both of these. This will leave us with x minus 5 over 2. And this would leave us with the square root of 57 over 4, plus or minus. So now we're going to go ahead and have x minus 5 over 2 equals plus or minus 57 over 4. And now we're going to add 5 over 2 to this side, or to both sides, to isolate my variable. And this will give me 5 over 2 plus or minus the square root of 57 over 4. All right, number 16 is yours to do. Number 17 says the area of the patio is 216 square feet. Write an equation that represents the area of the patio. Okay, find the dimensions of the patio by completing the square. All right, so we know that this is going to be, says write an equation that represents the area. Area is length times width. So it's going to be x times x plus 6. And that's going to equal 216 because it said the whole area was 216. X times x is going to be 2x, or no, actually x squared. And x times 6 would be 6x. Now we're going to get the square, find the perfect square of this. 6 divided by 2 is 3, and 3 squared, that's 9. So this is going to be adding 9 to both sides. With this. Okay. And now that we've added 9 to both sides, and so this was the equation that we had, right? Now saying find the dimensions. So once we have the equation and we found that perfect square, well, 216 plus 9 is going to be 225. And then we're going to have x plus 3 square over here. X plus 3 squared equals 225. Now we're going to get the square root of both of these. And now it's going to give me x plus 3, the square root of x plus 3 squared equals plus or minus 225. Now we're going to go ahead and remember that 15 times 15 is 225. So we're going to pull that out of that square root symbol. We're going to pull out x plus 3 out of this symbol. Remember that the square and the square root cancel each other out. Now we're going to subtract 3 from both sides. So our answer is going to be negative 3 minus 15, which is negative 18, or negative 3 plus 15, which will give us 12. All right, so 12 and negative 18 will be our answers. All right, let's move on. So, they wanted to say, find the dimensions of the patio by completing. If we know that it's going to be 12 because there's no such thing as a negative length, right? So it couldn't possibly be negative 18 here. That's why it had to be 12. All right, now let's move on. I guess they went a step farther and they found the length. So that, yeah, 12 plus 6 is going to equal 18. Let's go on to number 19. Solve by completing the square. We're going to subtract 15 from both sides. All right. For those that didn't remember that, we're just minusing 15 here. and then subtracting 15 over here. And that brings this down over here and brings it here. Now we're going to find the perfect square. We find the perfect square, we're going to take -8 divided by 2, that's -4, and we're going to square that, which will give us a positive 16. All right, we're adding 16 to both sides. -15 plus 16, that's 1. Over here, we're going to have the square root of, well, first we're going to have, square root of x squared, x plus, x minus, sorry, we use this symbol, x minus 4 squared. Okay, x minus 4 squared equals 1. Now we're going to get the square root symbol over both, and that's going to give us the square root of x minus 4 squared equals plus or minus square root of 1. And that's just going to turn into x minus 4 equals plus or minus 1, because 1 times 1 is 1. And now we're going to add 4 to both sides. 4 plus 1 is 5. 4 minus 1 will be 3. 20 is yours to do. 21 says solve the equation by completing the square. We're going to subtract 44 from both sides. Then we're going to find the perfect square of 20. Well, 20 divided by 2 is 10, and 10 squared is 100. So that's going to be adding 100 to both sides. Oh, they did do something unique here. I almost forgot. They factored out the 2, and that's going to simplify this a little bit. When they factored out the 2 here, they just left it with x squared plus 10x, and equals 44. So I'm not sure why it's written twice, but okay. Now we're going to go ahead and divide by 2. And that's what I wish they would have showed here. Instead of repeating this same thing here, they should have showed that they're going to divide this whole thing by 2, right, to cancel out these 2. That leaves us with x squared plus 10 on this side, and negative 44 divided by 2 is negative 22. All right. Now we're going to go ahead and take that 10 divided by 2, and that'll be 5, and then 5 squared would be adding 25 to both sides. I'm sorry about not seeing that factored out part a second ago, but yeah, even I miss something little every once in a while. So the other way you could have done it is right from the beginning to factor out the 2 from everything. And that's probably what I would have done. And it's best to do when you can't do it. If this is like a number that you can't factor out, then please go ahead and bring it over here and then factor these 2 out. So now we have 2x squared plus 20x plus 44 divided by 2. That's going to give us the x squared plus 10x plus 22, and then we subtract 22 from both sides. You're going to notice these 2 numbers here are exactly the same, or these 2 equations. Next, we're going to solve by getting the perfect square. 5 divided by 2, or 10 divided by 2 is 5. 5 squared would be 25. So we'll be adding 25 to both sides. What they did is they didn't put 25 over here. They just left it as 5 squared because they knew they were going to be taking the x, the positive sign, and the 5, leaving it there at 4 squared. Now you get the square root, well, 25 minus 22 would be 3. Now get the square root of each side with these. And that's going to give us x plus 5 equals plus or minus the square root of 3. And we're going to subtract 5 from both sides. This gives me negative 5 plus or minus the square root of 3. Okay. Let's move on. This is where they're showing you that this equation here is exactly the same as this one here. So whether you do it here or you do it here, you're going to get the same answer. All right, 22. Now this one, I can see they're going to divide by 3. I would divide by 3 right here, and that would give me 3 on the outside, and x squared minus 6x plus 4. All right. Now the way they probably started off though is subtracting 12 from both sides. Oh, I'm sorry. That was for you to do. Number 22 was yours. Let me go to number 23 before I give too much away. 23 says, well, yeah, we can combine these 2 here. If I do that, I'm going to subtract 10 from both sides. and we're going to factor out the 2 at the same time. It looks like what they did. And I'm going to fill in the blanks here. They minus 10 from both sides. That's what gave them the 16, 26 minus 10. And then they factored out the 2, and they said that 2x divided by 2 would give us x squared, and then, 2x squared divided by 2 would give us x squared, and then negative 14x divided by 2 would give us negative 7x. Now we're going to find the perfect square. Actually, we have to divide by 2. I'm sorry. I almost went to the next step again. We're going to divide by 2 again. This is going to give us 8 over here and get rid of our 2's. All right, now I have x squared minus 7x equals 8. Pretty sure what we could have done is divide by 2 across, and that would have gave us 13 minus 5, which would still give us 8. Okay, so let's move on from here. Oh, here we go. There we go. They took that square, that factored out the 2 from 2x minus 14x, or 2x squared minus 14x, divided by 2, and got 16 divided by 2. And that's where they got the answer here. Okay? Pretty much matching what we just showed you right here. The other way, I think, which would have worked, and I'm just going to demonstrate it over here, is if they would have factored out the 2 from the beginning. And let's see here. No, I'm pretty sure. All right, I didn't want to waste video time writing things down. But here I have the original problem, right? And then I divide everything by 2, because remember, I can go ahead and multiply everything to 3, I can multiply everything to 4, and it's still going to be equaling the same thing. It's just almost like like if I had a 4 over 4, right? Or 4 over 3, and then I multiplied the top and bottom by 2, right? I'm still going to get the equivalent of this, which is going to be 8 over 6. So that's the same concept here where I'm dividing everything by 2. Gives me x squared minus 7x plus 5 equals 13. Then when I subtract 5 from both sides, of course, that's going to leave me with x squared minus 7x equals 8. And as you can see, that's what we have right over here. Okay, so let's move on. Let's see. We've got, I'm looking for my arrow, there it is. Now that we've got that, we'll get the perfect square. This is going to be 7 over 2 divided by 2, which is going to give us a, well, that's going to give us a positive 49 over 4. Yep, there we go. Also add 49 over 4 to both sides, or what they did, they left this in the form of negative 7 over 2 squared. So they knew they were going to get the x out, the negative sign, bring it down, and then this would stay negative 7 over 2 that they were squaring. Now I got 8 plus 49 over 4. Again, I'd multiply 8 to 4 over 4 to give us 32 over 4. 32 plus 49 is 81. Okay, and that gives us 81 over 4. Now I'm going to get the square root of both of these, which cancels out my square. And we know that the square root of 81 over 4 is really 9 over 2. And that's how they got here, plus or minus 9 over 2. And the square root of x minus 7 over 2 squared is going to give us x minus 7 over 2. Now I'm going to add 7 over 2 to both sides. Now this is going to give me either a, see, 9 plus 7, which is 16 over 2, and that would be 8. Or I'd have a negative 9 plus 2, which would give me a negative 2 over 2, and that would be a negative 1. All right, let's move on. 24 is yours to do. 27 says write a function in vertex form by completing the square and match the function with its graph. So they're looking for where's the minimum and maximum. So write the function in vertex form by completing the square. So automatically, because this one doesn't have a negative in front, right? I know that it's going to be a parabola that's like this. So that leaves me with C or D, okay? I also know this ends in 3, so that means it has to cross through positive 3. So this is 4. This one here could go up. It looks like possibly C. Now remember they're saying write it in vertex form. To write this in vertex form, we have some steps we've got to follow. Sorry about that. We've got to take this 3. We're going to bring it to the other side, right? Got to pretend there's an equal sign over there. So we'll be subtracting 3 from both sides. And then we look for that perfect square. Well, we know that we're going to get a, let's see, x squared plus 6x. Well, 6 divided by, let's see here, this should be, yeah, 6 divided by 2 is 3. So we're going to have 3 squared. So we should have x plus 3 over here. Let's see. Yes, x plus 3 squared. And then we're going to subtract 6. You might be saying, where did the negative 6 come from? Remember that when we get that perfect square, this is going to become x squared plus 6x. And then this would have been plus 3 squared. Because 6 divided by 2 is 3, and I would have 3 squared here, right? And remember, whatever I add to one side, I add to the other side. So let's see, if this is going to be a 3 squared, that's really 9, right? So we're going to have 9 over here. Going to equal over here, right? And then we have 9 minus 3, which would give us a positive 6. And I'm just going to kind of put this over here, which would have given us x squared plus 6x plus 3 squared equals 6. And now, when we get this perfect square, we're going to have this, right? So that's what this is going to turn to this. When we factor out what binomials would equal it. And then we're going to bring this back over, and to do that, we'll have to subtract 6 from both sides, and that's where they got a negative 6 here. Now, remember, this is vertex form. So vertex form states this will be my x. I have to solve for it in the form of x plus 3 equals 0. And of course, that means I'm going to subtract 3 from both sides. So x is going to equal negative 3. And of course, this stays the y value, which is 6. So we have negative 3 and 6. And we did eliminate this one over here because we did say the y value is 4. Kind of knew it had to be d, but let's just verify that at negative 3, right, and negative 6 is our vertex, right? And this line obviously was going to cross through 3. Number 28 was yours to do. Let's try 29. We're going to try to do it the quick way this time. We're going to add 2 to both sides. When I do that, I'll find the perfect square here. 4 divided by 2 is 2. So I'm going to have 2 squared, which is going to be 4. I'm going to take 4, and on this side I'll have a positive 2. So I'm just going to work it a little bit over here. So at this point, let's see, I'd have, well, I guess I should factor out that negative first. And by having this negative, we knew that our parabola is going to be like, it won't be like this, it'll actually be like this. So we knew it had to be A or B, okay? And we also knew it had to cross through -2, which was a giveaway. So this tells me this one has to be it, without even doing any work, B. But it says write the function in vertex form, so we're going to continue it, okay? But I mean, it literally, it's little work here. We're going to have that negative factored out, okay? Hold on, I'm going to try to write it so I don't spend too much time in this video. All right, yeah, to make it quicker, I just wrote it out. First, we did factor out that negative, right? We'd move that -2 over to the other side and make it a +2. We'll get the perfect square. We'd have 4, which would be 4 divided by 2 is 2. 2 squared give us +4. We'll have to add 4 to both sides, but remember, when we bring that over to the other side, we have to multiply to this negative sign, so it'd be a -4. We'll have -4 plus 2, which gives us a -2. When we find the square root of it, or actually when we're seeing what binomial multiplied to itself equals us, it's x plus 2. So now we have -x plus 2 squared equals -2. We're going to bring back the -2 over here, which will make it a +2. Now we have negative x plus 2 squared plus 2, and when we solve for x, we get a -2, and the +2 comes down for the y value. Let's see how I did. Yep, there it is, negative x plus 2 squared plus 2. That's what we had right here. And the vertex would be -2 and 2, so that would be B. 30 is yours to do. So let's determine whether the quadratic function has a maximum or minimum value. Then find the value. Okay, so if we're finding this, we want to find out, does it have a minimum or maximum value? We're going to take our -30 here, and you see that we have the y value over here. We're bringing this over here to the y, okay? So it's going to become, we're adding 30 to both sides. Okay. So now we have y plus 30, all right? And let's see, we are bringing taking the negative, okay, over here we have y plus 30 minus 10x. So we see we're going to go ahead and take that 10x and find that perfect square for it. That's going to be -10/2 divided by 2, which is, and then square it, which is going to give us a 25/4. No, actually 5. That'll be 25. So now we have y plus 30 minus 25. And now you see they factored out the -1. Okay. That negative sign, they got rid of it. And next, they are taking the that 25, right? Y plus 30 equals 25, and that's going to be equal to, since they factored out that -1, negative x squared plus 10x equals 25. Okay. Once they've done that, they're going to go ahead and say that y plus 5, right? Y, the plus sign, and then square root of -25, well, that's going to be 5, is going to be equal to negative x plus 5 squared. Okay? And again, they took the x out, the positive sign, and then the 5 right here. Okay? So now we have, we're going to bring the negative 5 back over to this side. And that's giving us negative x plus 5 squared minus 25. Oh, sorry, minus 5. Sorry about that. So the vertex is going to be negative 5 and then negative 5. All right, 34 is yours to do. Oh, I'm sorry. Since the y value is negative 5, the maximum would be negative 5. We knew this was a negative, so that was going to make a parabola that is going like this. And the minute we found the y value was negative 5, then we knew the maximum was negative 5. Number 35, determine whether the quadratic function has a maximum and minimum value. All right, so it's in the function of x plus 9 equals negative. We're taking the 9 and bringing it over, right? Then we'll have negative, they're factoring out the 3 here, right? X squared, and then since we factored out the negative, this will be a positive 2x, right? We'll make sure it works right. Negative 3 times x squared would be negative 3x squared, and negative 3 times 2x would be negative 6x, so that works. Next, we're finding the perfect square of 2. That's going to be 2 divided by 2, which is 1. 1 squared is going to be 1. So that means we're adding one of those sides, right? So over here, we're going to have f of x is equal, or f of x plus 9 minus 3, and then times 1, right? So that just stays the same. And then we have a negative 3 times x squared plus 2x. And as I said, 2 divided by 2 is 1. 1 times 1 is 1. Now, we see here we've got x. The plus sign comes down and the 1. So we can take this binomial and square it to be this. We've got negative 3 that we factored out in front. We know 9 minus 3 is 6. And now we're going to bring this over and make it negative 6 on this side. And now we can see that our vertex would be negative 1 and negative 6. And now that means, since this is a negative value in front, the maximum value could be negative 6. Okay? 36 is yours to do. Looks like I did all of them leading up to lesson 9.5. So have a great night, and we'll grade in class.